large, the local maximum, the local minimum, or the absolute maximum, which is designated for actual minimum.
Can I take just my lunch today? I don't want to.
Is that right? Can you corroborate that?
So I just heard people saying maximum, minimum, absolute, and all that stuff. So in this graph, where, how do I want to say it? Where is a maximum? Andy?
There is a local maximum at x equals negative 2.7.
Okay, so exactly. He answered what I asked. I said, where is the maximum or a maximum? And he said x equals negative 2.7. He gave a lot more information as well. He said it's a local. Why is it not absolute?
Because it goes further up later on in the graph.
Because there are y values that are higher. Is there an absolute maximum?
Yes.
No, there's not. Why not?
Because it keeps going on here.
Because it keeps going on off into infinity. If you were to like Venmo someone the absolute maximum, you can't type in the specific number, right? Daniel, I am that irritating little sister. If I tell you to write down the number, I'm going to be like, add a couple of extra zeros between your number and the decimal, and my number's bigger. So I will be that irritating little sister, like, oh yeah, I can beat you. You can ask my siblings. They will attest to that. She's irritating. Okay, what's the minimum?
Good morning, BCC. This is Mr. Yates with an important announcement. Students, at this time, you should be in fourth period. Thank you for being in your fourth period class at this time. We have approximately 600 students who have still not completed the student expectations module. We will have a mandatory meeting for those 600 students today during lunch in the auditorium. These were the lessons that were done during homeroom in September. Your failure to complete these could impact your ability to attend school events such as homecoming dance, homecoming game, football games, basketball games, etc. We look forward to seeing approximately 600 of you in the auditorium at lunch. Thank you.
I don't think they really are looking forward to that, but it's what's going down.
How do we know from MLS?
I got an email to personally invite said students, which they have already been invited. They know who they are.
Can you call them out real quick?
No, I already did. You missed it.
Was I called?
You were not. You would know. So you actually paid attention in homeroom that day that you were supposed to do the things in the homeroom.
I skipped most of them.
Don't tell me la 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 la. Things I don't want to know. La 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 la.
Well, I guess
Okay.
it's the same thing every year.
All right, but back to this. So be careful of how they word things. If I said, when is the high temperature today? And you tell me 72 degrees, that's wrong. If I ask, what is the high temperature today? And you tell me 2 p.m., that's wrong. Like, did I ask, where is it happening? Or what is it? So, what is the high value? That is the y value. And again, there is no absolute on this one, because if you want to say infinity or negative infinity, that's a number that you can't write down. I want an actual number you could write on a check. Not that people write checks anymore, but. Okay, so extreme value theorems, that's what we're doing today. And pre-cal, absolute, global, same thing. It means the most of the most. And local or relative is just like, oh, I'm the tallest one, looking left and right. I'm tall. Okay, I might be around a bunch of kindergartners, so when I get back to the high school, I'm not quite so tall anymore. If you are a local maximum, could you also be a global? Yeah, Katie Ledecky. She happens to be a really fast swimmer in Bethesda. Oh, wait, and she also holds the world record. Cool. Okay. So the AP is not gonna make a big deal about that, but if they say, find all the local extremes, that also means the maximum absolutes as well. They say find all of them. Here's the math definition of what a high and a low is. It means this y value at this spot is bigger than or equal to all the others. That's all. And this is what a minimum is this y value is the lowest out of all of the y values. And someone always asks about the really uninteresting case. Yes, as a matter of fact, 3 is the absolute maximum and absolute minimum for all of the x's. If it's a just boring constant, you can have lots of absolute maxes and mins. Sine and cosine. Crap ton of places where it hits that maximum value of +1. Infinite number of places where it hits that absolute minimum of -1. Good? Some people are writing this down, okay? It's just alphabet soup way of saying across the domain, where all the x values are in this domain, that's the y value that's the biggest of them all. Good that all the backpacks wiped off the chalk on the board so I could look at what good times were. Oh well. Okay. So really fast, like I don't think these are worth writing down, but this parabola, absolute minimum is 0. Absolute maximum goes forever. Doesn't have a maximum. Okay, we're going to clip the domain a piece at a time. From 0 to 2, what's the absolute maximum, Felipe? 4. Where does the absolute maximum happen? 2. Absolute minimum, Paulo? 0. Where does it happen? Also at 0. Okay. So now, with an open circle here, there's no longer a minimum. Do you have an idea of, like, gee, when is the function going to be -2? That you can definitively say never. But you can't say what the all-time minimum is. And then the next one, oh, they're both open, so there's no absolute max, no absolute min. Yeah.
Wait, but couldn't you have like a value of like 3.999999999? You know what I'm saying?
So wherever you stop writing, annoying little sister, I'm going to add a couple more. So if you have to actually write the number down, I will shove more 9s in at the end and say, my number is bigger than yours, I win.
So wait, so like for example, like if we were to have like 2.5, would you keep adding? Wait, no, that makes no sense. Would you keep adding zeros? But that's.
Well, 2.5 in this case is nowhere near, like, I'd be like, 3,
Right.
gotcha, beat. Ha.
Okay, so it has to be like individual.
But if you're like sneaking up to that,
Yeah.
then you gotta write it down. You stop there, I'm gonna add just one more 9, that's all I need to do. Yep,
You can't just like write 3.99 with the line over it?
no hats, no hats, no hats. Okay, so part of the point of this, okay. Copy that down. If a function is continuous on a closed interval, then there is guaranteed to be an absolute maximum and an absolute minimum there. Guaranteed. Yeah.
Because the brackets are like inclusive, so it has to make some use of the endpoints,
So,
just in case those really matter.
okay. Yes. So he says, is that because it's a closed interval? Not just because it's a closed interval, but it's closed and continuous.
Yeah.
So that's like saying, everyone in the class is gonna participate in a race, you must play. And when marks get set, go, everybody runs to the end of the hallway, and I win because I tripped you all, haha, I am the fastest, and no offense, Sam, you came in last because you're still broken. So, there is a fastest and there is a slowest, but everyone had to participate. There will be guaranteed someone's fastest, someone's slowest. Now, if we, like normally, in a random race that isn't seated, meaning I didn't arrange everybody in their time trials, the maximum's gonna happen somewhere in the squishy middle. Maybe Ben was fastest and I was slowest, but he was third in the group and I was seventh, I don't know. So maybe the maximum and absolute maximum happened in the middle, or maybe I went first and I lost. Ben went somewhere in the middle, or maybe I went somewhere else. But, so, the point is, the ends might be those maximums. Maybe I lined everybody up by their time trial, and I made the fastest person go first, and everybody did their same time trial. It's not a surprise that it didn't happen in the middle if I organize it first. So, when I ask you for absolute maxes and mins, not only do you need to check where these things happen, but be like, wait, Andy started. Maybe Andy was the fastest. Maybe I ended, and I was slowest. All right. This picture's in your book. You don't need to write it down, but looking, what kind of function, feature, where do these maximums happen?
Horizontal tangent.
At horizontal tangents. So when we find the derivative and find where the derivative is 0, hey, maybe it's a high point, maybe it's a low point. What's this? What's the derivative there? It's a cusp. So what's the derivative there?
Undefined.
Undefined. So maybe I need to look for not just where are their horizontal tangents, but maybe where is it undefined? Okay. So maxes and mins might happen there, but keep in mind still, maybe the all-time low is at the end point. And maybe the all-time high is at an undefined. So we gotta like look for those things. All right, can you write down the words? A critical point. Critical point is just where's the first derivative, 0 or undefined. We will do lots of things with critical points, but that's its definition. And then find the critical points for this function. So critical point's not just where the derivative's 0, it's where it's undefined as well. Where is it undefined? What? Isn't? So, all right, where is it 0?
Negative 3/2 and 2.
Okay, so factoring. Okay, so critical points right there. That's all I asked for. Yep.
Is a critical point just in the X, or would you say like X, one?
Critical point is just the X. Because we'll have critical points, we'll find critical points of position, and then we'll find critical points of velocity, and then we'll find critical points of, we'll find critical points of various derivatives, and the Y value doesn't have a lot of sense to it. Not always. So there are my critical points. All right. Yep.
What is a critical point?
It is specifically where a function is 0, has a derivative 0, or the derivative is undefined. And what those critical points can be, like if this is my function, this critical point seems to be a maximum. It's local, the way I have it drawn. This critical point where it's undefined appears to be a local minimum. So if I want to check this one, well, first of all, I took algebra 2. It's a cubic, it was positive, so it's going to do something like that. So the first one is going to be a maximum, local maximum. That's a maximum, that's a minimum, and they're both local. Okay, to prove that to you, I'm going to take a number line, and I'm going to test the derivative at these spots. And I erase the derivative. Go me. 2x minus 3 and x plus 2. Is that it? Minus 2.
It was 2x plus 3x.
So it was a plus and a minus?
Yeah.
I got them backwards. Plus, minus. All right. So testing the derivative at 0, I get a positive and a negative. So that's negative. The slope was negative between the two of those. Testing negative 100. I get negative times negative, which is positive. Testing 5. I get a positive times positive. And I didn't put any bounds. I didn't restrict it. It's all reals. So this means the function was with a positive slope the whole time until here. And then it had a negative slope until there. And then it had a positive slope. So finding critical points, it could be where maximums and minimums happen. Does it have to be? No. We'll get to that in a second. Okay. Like I said, this one. Find the critical points. Y equals x cubed. Alana's so fast. Alana, what is it?
X equals 0.
It's not undefined anywhere. Critical point at x equals 0. And then I didn't ask in the question, but is that spot a maximum or a minimum? Let's check. Yoav picking a negative number, testing the derivative. Is the derivative going to be positive or negative? Positive, okay. Evelyn picking a positive number, putting it in the derivative. Do I end up with overall positive or overall negative? Positive. So this says it was going up, and it stayed going up. So that critical point, which it is still a critical point, it's not a maximum, not a minimum. That's your standard, hey, I came up to the stop sign, paused, and then kept going forward. Not a max, not a min. Do you guys know what that's called? It's an inflection point. We will do that more later. But in politics, they often talk about the inflection point of the campaign, when everything looked like it was winding down, it was gonna be crappy, and then, oh, look, it turned around. Or the inflection point in the war, good times. Okay, find the critical points. Where's the critical point, Andy?
X equals 0.
X equals 0. It's not 0 there, it's undefined. So, all right. And if I want to check, is it going to be a maximum or a minimum? Putting in a negative or a positive, it got squared first. It is a critical point, but it's not a maximum, it's not a minimum. Cool? Okay. All right. They will make a big deal about find the fastest of the fast, find the slowest of the slow. First thing, identify your domain. Who's allowed to get on the ride? Are you this tall? You must be this tall to ride. So identify your domain. Then find your critical points. Do the first derivative, find where it's 0 and undefined. Identify them all. And then you make a T-chart with, if your domain was restricted in any way, your endpoints, and all your critical points. And then there's the tedious job if you got to plug them all those x values into your function and get the y values. And whoever's the biggest y value of everything in that chart, he's the winner. And whoever's the lowest is the loser.
Also the winner, just different.
Sorry?
Also the winner, just different winner.
Different winner, right? Maybe the point was to have the least amount of whatevers. Milo, pick a number, negative number.
-4.
Negative 4. Francesca, pick a positive number.
1.
Constantine, pick a number in between them.
3.
Okay. So, find the absolute max and min, if possible. Bless you. How do I even do the derivative?
Chain rule, it's x minus 3 in parentheses to the -1. And you can change that into -1 over x minus 3 squared.
Okay. I see that as power rule, but also a chain rule. So my critical point, where's the place that it's undefined? At 3. So checking endpoints. These are the x values. And my critical point, -1/7 and +1/2. What is the value at 3? Undefined. Something's wrong. Because I said, for the extreme value theorem, everyone in the room's in the race. It's guaranteed that there will be one fastest and one slowest. How do I reason with this?
It's an asymptote.
It's an asymptote, but
It's not.
oh, wait a second. It's not continuous. It had to be continuous for that guarantee to be in there. So my guarantee was off, but so we do know what that looks like. At x equals 3, it's gonna swoop and swoop. I don't know. I don't think I have an absolute max or an absolute min because I'm here and there, and these guys go that way, and this guy goes that way. So no absolute max, no absolute min. There's a local of each. Yeah.
The local is those two.
The local maximum is the -1/7,
Yeah.
and the local minimum is the 1/2.
The
And -1/2. Okay.
Oh, we know.
Pause it, because I plug into the function, not the derivative. Yep.
Wait, so this only applies if the function is continuous over the interval you're evaluating?
So the extreme value theorem that I asked you guys to write down said, where'd it go? The function had to be continuous and on a closed interval.
But you could give us like a discontinuous function, but give us an interval where it is continuous.
Mm-hmm.
Yeah.
So this one, it is a continuous function, but I'm not making it a closed interval. Find the absolute max and the min if possible.
Minimum is 0, maximum doesn't exist because it's sort of a open circle.
Okay, so statement is,
Does this make a max?
critical point,
Or, like, the-
it's undefined at 0, and Daniel's saying he made his little T-chart. Okay. Whether it's included or not, it goes in the chart. And I would put a circle around the ones that have an open bracket. Like, that's just my personal notation to tell myself, if the high point or low point happens at that X value, it is not the maximum, or it is not the minimum. Okay, plugging in -1 squared became +1, cube root of +1 is 1. And what is 8 to the 2/3?
4.
How did you get that? Did you square it, then do the cube root?
Like cube root squared.
Okay, well, it matters, because I've had students that were like, I don't know how to do this fast. I make numbers smaller before I make them bigger. So cube root of 8 is 2. 2 squared is 4, rather than 64, cube root of 64, like. Okay, so there we have our table. And now, like, people always ask, how do we know that nothing else could have happened in between these two?
Because it's not a critical point.
Okay, so, I mean, what this looks like, this function, is like that. And if I was to have some other mysterious maximum or minimum in between, I would have had to have other critical points. So finding the critical points means guaranteed there's no funny business happening between 0 and -1 and 0. There cannot be, because if there was funny business like this, I would have needed more critical points. They should have shown up. And same with this side. So it's not doing anything funny like that. It's got to be a smooth curve, because I would have found more critical points or more undefined spots. So Daniel said there is a local maximum of 1, an absolute minimum at 0, and there is no absolute maximum because this one was an open circle. Sam?
Okay, so can you just clarify just once again why you said we still have to include the 8 even though it's open circles?
Well, if it's not in my table, so if this is gone,
Oh, you want to find out that that's the highest point. Technically, but it's not the.
yeah, it would have been the highest point if it was included.
Okay.
But that it's not included, I don't have any highest point because the annoying little sister thing. Yeah.
So yeah, if the 8 wasn't there, then 1 would be the absolute max,
Well, so,
or you wouldn't know.
I mean, I need some end over here. If my end is a half, like, first period said, well, if it was that, would there be an absolute maximum? Yes, because at -1, the y value is +1. It's closed for this guy, so it hit that value. So yes, there will be an absolute maximum if I do this funny business. Yeah.
When you're solving over an interval, you say absolute, like min to max is for the interval, even if like on the actual function that it's on, there might be smaller or bigger values, but for the interval, it's the absolute max.
Okay. If I have a continuous function over a closed interval, you are guaranteed to have a fastest and a slowest. Guaranteed. The example that we just did here, it wasn't continuous. So I was a pain with that. So it's not a guarantee. It could happen anyway, even if it's not continuous. In this one, it's not a closed interval, so I might have an absolute max, which if these were reversed, I do have an absolute max and I do have an absolute min, even though it wasn't a closed interval. My absolute minimum is still at 0. My absolute maximum would have been 4 at x equals 8. Yeah? Yeah.
What if the function has 2 maximums and they both like go up to the same amount? Like would they both
Like-
be absolute maximums?
You mean like sine? Sine has an infinite number of maximums. They are all 1.
Okay, but would they be considered absolute or local?
Yeah, they're absolute. Like, you cannot get taller than 1 on a sine function. You cannot get lower than -1. They are all their absolute maximums and minimums, and they happen in an infinite number of places.
Do you write all the x's or the?
Oh geez, they're not gonna ask.
Okay, or what if it's like 2 and they're the same? Both x's.
In those situations, I've seen them say, what is the high, not when.
Okay.
So if it happens a whole bunch of times, like, oh, it's 72 degrees, welcome to California. It's 72 degrees again, welcome to California. Like, come on, you get bored of it after a while. They're not gonna be like, oh, at 2 and 2:15 and 2:37, like, yeah. Okay, try the homework.